New Zealand is defined by water. With a landscape carved by glaciers and alpine lakes, and a population density of just 20 people per square kilometer, the country appears to have an endless, untouched supply of fresh water. This chart shows the psychological result of that abundance. The average citizen consumes about 280 liters of water every single day, a high usage rate driven by the perception that the resource is limitless. But that consumption masks a severe logistical disadvantage. A tiny tax base is forced to fund and maintain thousands of kilometers of pipes, pumps, and treatment facilities spread across a vast, rugged geography. Raw, natural fresh water sitting in a pristine lake does not easily translate to clean water flowing reliably from a tap. The sheer scale of the terrain turns a massive natural advantage into a complex financial hurdle, making basic infrastructure maintenance disproportionately expensive. The strain on the system becomes visible when we look at the country's economic engine. Almost a third of the entire national population lives right here in Auckland. Currently holding about 1.8 million residents, the city is on a trajectory to surpass 2 million people within the next decade, applying immense friction to a legacy sewerage and water network designed for a much smaller town. At the same time, climate change is stripping away the region's natural reserves. Over the last 20 years, the total glacial ice mass supplying these watersheds has plummeted by 42%. Outside the city, the land is working harder than ever to support the economy. Since 2002, the total area of irrigated agricultural land has doubled, and cattle farming operations have nearly tripled. The resulting runoff from this intensive farming, combined with urban expansion, means that more than half of the nation's rivers now register critical levels of pollutants and harmful nutrients. Auckland is a modern, rapidly expanding metropolis that is quickly exhausting an aging, surface-level life support system. To prevent the city's growth from collapsing its own ecosystem, the Regional Public Water Authority, Watercare, is forcing a massive infrastructural pivot beneath the surface. Watercare is deploying a $13.8 billion New Zealand dollar, or $8.2 billion US dollar, investment program. The funds serve a dual purpose: replacing critically degraded surface pipes and carving a new, high-capacity wastewater network deep underground. This requires lowering massive tunnel boring machines beneath the densely populated streets, excavating thousands of tons of dense volcanic rock without disrupting the city above. By installing oversized concrete shafts and wide-diameter pipes far below ground, engineers are creating a massive physical buffer large enough to safely hold volatile urban demand peaks and extreme storm runoffs. Capturing this volume underground directly relieves the pressure up top. It physically prevents raw overflows, giving the heavily polluted urban waterways a necessary chance to filter out and restore themselves. To survive the pressures of climate change, a city cannot rely on its natural geography. It has to physically engineer a climate-resilient layer into the bedrock. Executing subterranean civil engineering at this depth and scale requires specialized global industrial expertise. New Zealand has a history of executing this tier of complex water engineering. In 1983, the WeBuild Group completed construction on the Tongariro Power Scheme. By meticulously harnessing and redirecting the kinetic flow of dozens of rivers and streams, that single hydro plant generates roughly 4% of the nation's total electricity, powering 160,000 households today. The mechanics of generating hydroelectric power in the mountains and controlling municipal wastewater in Auckland rely on the exact same principles. Both require massive industrial planning to forcibly redirect the natural water cycle. Ensuring the continuous flow of urban water is now a hyper-complex frontier of global industrial engineering. Auckland's subterranean megaproject acts as a microcosm for an urgent shift in global urban planning. The historical model of treating water as a passive, natural resource to be tapped has reached its functional limit. Planners now recognize this resource as blue gold, a strategic infrastructure asset that must be aggressively engineered and protected. As global climate variables become increasingly extreme, treating the entire water cycle as a highly controlled, engineered system is the only physical way a city can adapt to unpredictable droughts and sudden floods. Without these massive, integrated systems to process and filter the flow, explosive demographic growth will simply drain and collapse local ecosystems. The survival and sustainable development of tomorrow's megacities relies entirely on the massive, invisible underground arteries we build today.